talking about the MyFlood package here. And for those who know a little bit about the Mike products before, they know the Mike 11 is an engine that does something, Mike 21 is an engine that does something, and so what does MyFlood do? Does it also do some simulations on its own? And the question to that is no, it does not. MyFlood is actually a framework that allows us to couple existing models within the product suite. So the MyFlood is an integration between the combination of one-dimensional, two-dimensional models to calculate floods, assess flood problems in urban areas, in coastal areas, maybe in riverine flooding, in different floodplains. So we all see different kind of pictures of different flood events, so they being from rivers caused by spilling from rivers. It is within the cities that we see it often, that gives us a lot of problems. And it is along the coastlines where storm surges and other events causes flooding along the coast, so sea from the sea. To deal with these kind of sort of interacting water bodies, which is basically what we have here, is why we developed this MyFlood some years back in time, because it is an integrated tool that then can deal with these kind of problems, for instance floodplains, storm surges, urban drainage. I was saying dam break simulations before. You can put in, simulate a dam break and see what actually happens, how big an area is being inundated as a consequence of the break in the dam. And yeah, eventually climate change impacts. What would that do for us in our local area? How much would that increase the risk of being flooded? Now, the conceptual way MyFlood is working is that we would have, in this case, illustrated with a Mike 11 model. So that could be a river coming here, running out through the estuaries and into the sea. We would represent that with the Mike 11 model, as mentioned just before. We could combine that with the Mike 21 model. In this case, it's the Bay of Bengal. We represent that with the two-dimensional model. In order to make these two existing models interface and, I would say, talk to each other, that means exchange water between the two models, we are using this MyFlood framework to define where are the models coupled, how are they linked, and how do they sort of exchange water. So at the end of the day, this becomes a dynamic coupling between a model that does 2D modeling to perfection, I would say, and a model that does 1D model, each of them optimized for that. And we just make sure that whatever water goes in one or other directions are being exchanged between the two models in a correct way. MyFlood allows different types of couplings, from couplings between a surface model and a river model, to actually do, say, what we call it three-way coupling, but it's a full integration, you can say, between urban areas, between the rivers or streams running through the urban areas, and eventually also the surface or the sea. So we can actually combine three different types of models. The Mike 11, the 1D river model, the Mike 21 being one of the two simulation engines that is available, and then the Mike 11 model, which is a pipe model, it's a sewer model, collection system model. Right? From a user perspective, when you start working with it, you open the interface, it looks like this, and basically what we're doing is to bring in the different models, here being the urban model, here we have the river model, and out here we actually have the sea. So coupling these three models together and let it run, the models will interact. Just to show an example of an animation here where we have a linking between the river model. We have a river model that comes actually here, going down there. Actually the river will continue this way. But several events have shown that the water in this area, which is in the USA, actually took some different routes that were not expected. So MyFlood was used to determine, the water goes in that direction and actually floods this part of the city. And nobody was actually able to show that before we took the approach of combining models, because there's no possibility that a Mike 11 1D model that goes in here can actually tell us that we will have flooding in another area. Another example was the urban flooding, where we are coupling the pipe system of a city, collection system, and whenever the capacity of the pipes are not big enough, water will go on the surface. That water that goes on the surface will then be taken by my 21 model, so the surface, two-dimensional model on the surface, and then transported or routed on the surface. Eventually, water can go from one manhole literally down the road and down, drain back into another manhole. So for that reason, this dynamic interaction is very important to do a correct, say, assessment of eventual flood problems, also within urban areas. And at the end, kind of the same animation, you can say, but the example that I mentioned before about three-way couplings. Here we have an urban area, we have the sea out here, we have a river that goes up there. Everything is, all the three models are sort of connected, combined to each other. So what we have is a spilling from the river into the urban areas, into the surface. Interaction between the outlets from the urban pipes and the river. We have an interaction with the tidal elevation, and then the urban pipe system is linked as well. So there we have a full integration of three different type of models to give a very, say, accurate or detailed picture of flow patterns within an urban area. So to summarize the MicFlood package, because sometimes we often have the wrong interception of that, the MicFlood in itself is not an engine. It's a framework that couples different models together.